In this chapter, we look at the last main ingredient that can be used to explain cross-country income differences, and this is productivity. And in this chapter, we will decompose productivity into its two components: true technological differences between countries and differences in the efficiency of the economy, for example, the efficient use of production factors, and whether technologies that are used are appropriate for the circumstances in such a country. Again, this chapter is based on the textbook treatment by David Weil, Economic Growth, Taylor and Francis in the third edition. So far in the previous videos, we have focused on the rival production factors in explaining cross-country income differences. So differences in physical capital, mainly determined by differences in saving and investment across countries as predicted by the Solow model, and differences in human capital, mainly in the form of education, but we also discussed that human capital differences can arise due to differences in health and experience, for example. And this was based on the Mankiw-Romer-Weil framework. And there we have altogether seen that we can explain a certain part of cross-country income differences by these two accumulable production factors, accumulable rival production factors, but that a large part still remains unexplained. And the main ingredient to explain this last part, the missing ingredient, if you will, is productivity that we denote by A. And in this video and in this chapter, we will also disentangle A into its components, true technological differences between countries, and differences in efficiency. That means in the efficient use of production factors, and also, for example, whether the technologies that are used in a country are appropriate for the circumstances in that country. Before we do that, a short graphical illustration of our analysis so far. So we looked at basically two countries. Country one had a certain endowment of human capital per worker and physical capital per worker, and therefore along its production function would have a certain output per worker. Now another country, that was country two that we compared, came with different levels of human capital per worker and physical capital per worker, higher levels, and therefore it would be on higher part of the production function and would be able to produce more in terms of per capita output, as it is drawn here, where country one has a lower per capita output than country two. But what also could happen is the two countries share the same amount of production factors, human capital and physical capital per worker, but still have different per capita levels of income. So for example, as it is drawn here, you would have countries 1 and 2 having the same H and K levels, but country 2 would still have a higher output per worker because of the fact that it features a higher productivity level A. So basically the production function would be a different one. It would be shifted counterclockwise in this case around the origin, such that this country would have a higher output per worker for the same human capital and physical capital stock per worker. However, you can also have differences in both production factors, the rival production factors H and K, and productivity A. So as it is drawn here, country 1 would have a lower human capital stock and physical capital stock per worker than country 2, and at the same time country 1 would also feature a lower productivity level A than country 2. So in this case, we would have that the income differences between country 1 and country 2 can be explained by the differences in the rival production factors H and K. That would be this distance here. So from here to here, basically, this part of income differences can be explained by different production factors. And the remaining difference from here to here can be explained by differences in productivity. And that's exactly what we will look at now from this cross-country perspective that we had before in the previous lectures. Now the question might come up why we look at productivity as the last component. And here this is mainly a measurement problem. We can measure, in principle at least, the stocks of rival production factors, physical capital per worker and human capital per worker. Of course, we can only do this imperfectly, so by proxying the different components. but at least we could in principle measure it. Productivity is, however, not observable and can only be measured indirectly as the residual that is left unexplained by the other components up to now. And now for this exercise, we again assume a Cobb-Douglas production function of the form that we have here, where productivity multiplies the production function altogether. We have that output is a function of productivity, physical capital with an output elasticity alpha, and human capital with an output elasticity of 1 minus alpha, where human capital, we again use this more conventional formulation, is the product of average human capital per worker multiplied with the number of people who are working in the economy. Now we again do this for two countries. So we have country 1 with productivity 1, capital intensity K1 to the power of alpha, and human capital intensity H1 to the power of 1 minus alpha. So that's basically again per capita output, so the aggregate output divided by the number of workers in the economy. And for country 2, it's analogous, just that for this country we have different levels of the different production factors. Then we again compute the ratio of per capita GDP of country 1 and country 2, and we decompose it into these two parts. So we have capital per worker and human capital per worker here in the second term within parentheses, and these are the observable differences between the two countries. And we have the first ratio here between the productivity levels A1 and A2 in the first parenthesis, and that's the unobserved part of the cross-country income differences. So everything here can be directly measured, per capita GDP on the left-hand side, and the stocks of physical capital and human capital per worker, except, and that's the productivity difference, which cannot be measured. But now we can reformulate this equation, take the productivity differential to the left-hand side, and then we would have that the productivity differential between countries 1 and 2 is given by the output differential or income differential of the two countries divided by the contribution to output of the differences in the rival production factors, also on the right-hand side. So this is can be easily shown. You can just divide this expression here by this term, and you exactly get this term here. And now we have everything that can be measured on the right-hand side and the things that cannot be measured on the left-hand side. Now moving further onwards, we decompose productivity and productivity differences across countries into the components, the true technological differences between the two countries, denoted by uppercase T, and efficiency differences, and we denote efficiency by an uppercase E. Now first, what's technology at the core? So that's most broadly defined as ideas or blueprints or descriptions of production processes that basically allow to combine a certain amount of raw materials in new ways such that the outcome then is either better or more of the outcome. That's basically that we improve the recipe of production by having these new ideas, better blueprints, better production processes, and so on. Often they are protected by patents, so particularly in case of applied research. So if a firm comes up with a new idea and does a patent application and it gets the patent, then this typically lasts for 20 years, during which this particular firm who introduced the invention is then allowed to use it exclusively for a period of 20 years. So a monopoly is basically granted to this firm, and therefore the firm can siphon monopoly rents, and that's a huge incentive to invest in research and development to come up with better technologies in the first place. Now, examples for these better technologies are, of course, new products. So, for example, the smartphone can be seen as a new product that was not there previously, and research and development was used to come up with such a new product. Or a new vaccine, just now in the case of the COVID-19 pandemic, the new vaccines that are that we came up with, basically, that this would also be a new product in this sense. Or technological progress could also take the form of a higher quality of existing products. So for example, if you compare cars from 30 years ago to today, then you will see that they are more secure actually for the passengers. They are typically more fuel efficient and of course much more convenient. You have all types of air conditioning and so on that you might not have had 30 years ago. So the product just became better, and the higher quality of products, that also is also a manifestation of technological progress. And third component would be new production processes, so that you do not produce a new product or increase the quality of the product, but you would be able to produce more of the products for a given amount of input factor. So for example, the assembly line might be an example for that, where you just are able to produce more productively, or the use of industrial robots along the assembly line that substitutes for workers. Now, on the previous slide, we referred to true differences in technologies across countries or also over time. And now we ask the question what efficiency actually is, and differences in efficiency. And that's mainly determined by differences in the output level for given endowments of the production factors and technology, where it could be the case that even though two countries have the same technological level, the same production inputs, the same amount of production inputs, still one of them produces more than the other, and then the country that produces more would be more efficient. You can illustrate this, and we will do this on the next slide, by a production possibility frontier, where basically the production possibility frontier itself is determined by the technological frontier, and inefficient economies would actually produce below the production possibility frontier, and the degree of inefficiency would be the distance to the production possibility frontier, so the extent by which they produce inside of their production possibility frontier. Now, what could be potential explanations for such inefficiencies? Well, there are many, and we will discuss them also later on, but the most important ones are unsuited technology. So, for example, you might be in a country where you use the most recent technologies, but they might just not suit the circumstances in this country well. For example, if you use the best and largest harvesters, but the country that you are concerned with is a rather small country where agriculture is split into family farms and each farm has only a small amount of land, then this huge harvester might not be the most efficient technology to use. It could also be that there is a lack of suitably trained workers for the given technology, so they might not know how to operate them. Regulation might be such that the country is somehow strangled by regulations and so on and so forth. All that would lead to a lower efficiency. Now, if a country increases efficiency, that would increase its per capita output and per capita income because the country comes closer to its production possibility frontier. But increases in efficiency cannot lead to perpetual growth because at some point, of course, the production possibility frontier is reached, and perpetual growth can only be generated by true technological progress in the very long run. However, differences in efficiency can still explain cross-country per capita income differences rather well, and we will see later on that a large part actually of cross-country income differences can be explained by efficiency differences. What I said on the previous slide can be illustrated by a production possibility frontier. So this would be a production possibility frontier for a country that produces two goods, good 1 and good 2. And if it makes efficient use of all resources in production, then, for example, if it puts all the resources in the production of good 1, it can produce this amount. By contrast, if it puts everything in the production of good 2, it can produce this amount. And all the combinations along this curve would be feasible. And if the country makes efficient use of production factors, it could produce these points. So all points along the curve are feasible and efficient. So that's the production possibilities frontier. It's the most that a country can produce for the given technologies with the production factors it has at its disposal. Now, the points outside the production possibility frontier, they are infeasible. So for the given technologies, the country could not produce this point here in terms of output of good 1 and output of good 2. So that's infeasible. And all the points inside the production possibility frontier, they are inefficient. The country can produce them, but here it does not make efficient use of its production factors for the given technologies. And the extent of the inefficiency, as I said before, is the distance to the production possibility frontier. So if the country moves into this direction, it becomes more efficient. If it moves towards the origin, it becomes less efficient. And now, if a country becomes more efficient, that was what I said at the end of the last slide, at some point it will reach the production possibility frontier and no improvements in efficiency are possible anymore. So it cannot in the long run grow just by improving the efficiency. In the long run, it can only expand its production by moving the production possibility frontier itself outwards, and that is done by technological progress. Formally, we can write it down as it is done here. So productivity would be the product of technology T and efficiency E. And now we ask ourselves how much of the remaining cross-country income differences that we could not explain by differences in physical capital per worker and human capital per worker can be explained by these two components, technology and efficiency. To do this decomposition, we start with a thought experiment. Here, we pose that we observe a low-income country that we denote by Li versus a high-income country that produces the technology frontier, so uses the most recently developed technologies. And this is denoted by TF for technology frontier. Now, we assume that the low-income country lags by T years behind the technology frontier. Then we can write the technological level in the technology frontier at time t as the technological level in the frontier country at time 0 multiplied by the growth factor, where we denote the growth rate of technologies again by g. And this is raised to the power of t because t years went by from time 0 to time t. And now that's by assumption exactly the technological level of the low-income country at time t, but multiplied by 1 plus the growth rate time to the power of t, because it lags t years behind the technology frontier. So the technology frontier technological stock today is actually the technological stock today in the low-income country multiplied by the growth factor that we have to the power of t here. And now we can reformulate this to express the technology gap between the two countries as a function of the rate of technological progress and the number of years that passed by, or that we assume that the low-income country lags behind the technological frontier. So this is easily seen. We bring this term here to the right-hand side and this term here to the left-hand side. If we do so, we get 1 plus g to the negative t in the exponent, and that's the technology gap between the two countries. Now we assume that technological progress happens at 1% per year, an assumption that we also used previously in this course. And we additionally assume that the low-income country lags 10 years behind the technology frontier. That's just a number that we put in. It has nothing to do with the real world for the moment. It's just for the sake of illustration. So if we plug in these two numbers, so here 1% for the rate of technological progress and here 10 years, we would get that the technology gap between the two countries would be 0.91. So the low-income country would have 91% of the productivity of the high-income country if the difference was solely due to productivity. So that would be 91%. And now one can assume all different lags between the two countries, and the higher the lag is, so if the country lags behind the technology frontier for 20 years, then this value here would become lower, so the low-income country would exhibit a lower percentage of the income of the high-income country. Now we also consider efficiency. We already know that the productivity was decomposed into technology and efficiency, and we can write this down for the low-income country and for the technology frontier country. And then if we have that, we can again compute the gap. So divide the low-income country by the technology frontier, and we get the technology gap in terms of technology in the productivity in the low-income country divided by productivity in the frontier country would be the ratio of technology times efficiency in the low-income country divided by technology and efficiency in the technology frontier or high-income country. And from this we can isolate actually the efficiency component by isolating this term here, and the efficiency component of the differences between the two countries would then be the productivity gap between the two countries divided by the technology gap of the two countries. And now we can plug in what we already know. We already know from the chapter on human capital, the previous chapter, the previous video, that the remaining productivity difference between high-income countries and low-income countries that we can still not explain by physical capital accumulation and human capital accumulation is a factor of 5. So that means the low-income country would have 20% of the productivity of high income countries. And now we can just plug this in. So this gap would be 20%, so 0.2. And if we assume a technology lag of 10 years, then we plug in the 91% in the denominator, so the 0.91, and we would get actually an efficiency gap of 0.22. So in this case, the low-income country would have an efficiency level of 22% of the technology frontier. So the low-income country would actually be rather inefficient. And now we can extend this thought experiment that we had before and do a more thorough and systematic analysis of the differences between the two countries in terms of the technology gap and the efficiency gap. And in this more systematic analysis, we assume different technology lags. So 10 years, that would be the one that we already assumed. So the technological ratio between the two countries would be 91%. For 20 years, it would be 82%, for 30 years, 74%, 40 years, 67%, and so on. And when the difference is 100 years, then the low-income country would have 37% of the technological capabilities of the high-income country. And now we can compute for each of these technological differences the implied efficiency ratio. And for 10 years, we already know it would imply that the low-income country has 22% of the efficiency of the high-income country. For a gap of 20 years, it would be 24%. For 30 years, 27%, and so on. And for 100 years, 54%. So that implies actually that we can explain a rather small part of the differences between the two countries in terms of true technology differences, because it's really unrealistic that a country lags behind the technology leaders for, say, more than 50 years or something like that, and that efficiency would play a rather important role in explaining the cross-country income differences. So that's also the topic of this slide here, namely which combinations actually make sense. Now, we already discussed that patents are usually valid for 20 years or so. So we could assume that if technologies are introduced in high-income countries, then it takes at least these 20 years until the technologies potentially also arrive at the low-income countries. Of course, it could be earlier because a firm that invents the technology could also produce there and so on and so forth. But in reality, of course, those firms mostly produce in high-income countries. And that the technologies become available after the 20 years is more a theoretical argument, because, of course, we have barriers to knowledge and technology diffusion. Language barriers matter, regulation barriers matter, investment biases matter, and so on and so forth. So it's likely that the technology gap might be a bit longer than the 20 years. However, it's also not that likely, as I said before, that the difference is 100 years or so, because even low-income countries nowadays, I mean, they use very high-tech products, and firms produce also with production facilities that are not as they were 100 years ago in high income countries. So most likely from that perspective, the technology gap would lie between 20 and 50 years. But recalling again the table that we had on the previous slide, it still means that efficiency is rather important in explaining cross-country income differences, because even for 50 years technology gap, it would still mean that the efficiency of the low-income country would be only 33% of the efficiency of the high-income country. Well, since efficiency is such an important contributor to the explanation of cross-country income differences, it's important to think about where the efficiency differences could come from. I already said that unsuited technologies might play an important role. For example, the large harvesters that might be useful in the United States and Canada and so on, but not so much in countries with smaller agricultural farms or family farms. So there the technology might not be useful at all, even if it's present and even if it would be available in principle. Then, of course, unsuitable education, such that people could not use the newest technologies, for example, a lack of IT experts and so on and so forth. And in low-income countries, of course, that is also often the case due to the fact that people emigrate to high-income countries if they have such a good education, because the wages that they could earn in high-income countries are much higher than the wages they could earn in low-income countries. So this brain drain is also an important aspect that could explain cross-country income differences. Of course, then it's also difficult to disentangle that from differences in human capital in the first place. Differences in the economy structure, so for example, if the agricultural sector is rather large and many people work there because of inefficient farm size and so on, then the industry sector could not grow that much. And this inefficient structure of an economy could also explain differences in per capita incomes. Then, of course, regulation differences, particularly of labor markets. So if labor markets are regulated in a way that is that they are highly efficient, where hiring and firing is common and so on, a flexibility of work schemes, then this could imply that the country with more flexible regulations would also have a higher per capita income, because the frictional and unemployment might be lower in the long run, so the equilibrium unemployment level. Holidays and vacation rules would also play a role, of course. If a country has twice as many vacation days as another country, then there would also be a level shift in per capita income. Then, of course, all types of bureaucratic problems and barriers. If bureaucrats are corrupt, and then it takes longer for projects to get granted and so on and so forth, and even going to kleptocracy, where they steal from the overall population, of course, all that would lead to huge efficiency losses. Rent seeking, also going in this direction, where special interest groups lobby for them to have advantages on the costs of other groups, and of course, that imposes also efficiencies and also costs on enforcing property rights. Then geography could also play a role. If the soil quality of a country is lower, or if there's more heat and so on, then agriculture is not that productive, and then this would have repercussions again according to the economy's structure. If there are diseases in tropical areas, for example, that could have an effect. If a country is landlocked, then it would have more difficulties to trade with other countries. Also, this could have an effect. Or if the terrain is very hilly or difficult to navigate, then this would also potentially lead to differences. And of course, culture, work ethic, religion might also play a role. There is this famous hypothesis of Max Weber that the Protestant work ethic had a positive effect on per capita income in the countries in the Protestant countries, basically. And all these different aspects could lead in principle to differences in efficiency, and one might well imagine that they lead to such high differences of a factor of 3 that we have found out are needed to explain the cross-country income differences if the technology difference is 50 years. So overall, to summarize, we can now explain the rest, the factor of 5 in low-income countries and high-income countries by differences in productivity. And we can derive then a range of plausible differences in terms of technology and efficiency that explain the differences in productivity that we observe between high income and low income countries. And then taking everything together, differences in production factors and differences in productivity, and then the production factors, again, differences in human capital and physical capital, and differences in productivity, decomposing it to differences in technology and efficiency, we can then basically explain the differences in per capita incomes between high income countries and low income countries. And basically, the whole idea is still in the initial Solow model, but extended in various directions. So from our modeling circle, we now came back. So we have improved the model several times, included human capital, decomposed productivity into efficiency and technology, and so on and so forth. And finally, this final model would be able to explain the cross-country income differences, and with human capital, the model also leads to a convergence rate that is consistent with the data. So finally, then the framework passes the empirical test.